Calculus, differentiation from first principles, polynomials. Here's an example of a polynomial. It's 7x squared plus 4x plus 7. We're going to differentiate it now with respect to x from first principles. So we write the equation out, y is equal to 7x squared plus 4x plus 7. And everywhere we had y, we're putting in y plus delta y. And where we had x, we substitute x plus delta x. So y plus delta y becomes 7 into x plus delta x squared plus 4 times x plus delta x plus 7. Or y plus delta y is 7 into x plus delta x times x plus delta x instead of the square, plus 4 times x plus delta x plus 7. Y plus delta y is 7 into x squared, x by x is x squared, x by delta x, and x by delta x gives us the 2x delta x, and the delta x by delta x gives us the delta x squared. So we get 7 into all of that, plus 4 times x plus 4 delta x plus 7. So expanding the whole lot out, if we take this line here and substitute the y from it, we get y plus delta y minus y is 7x squared, 14x delta x, 7 delta x squared, plus 4x, plus 4 delta x plus 7, minus this part up here, 7x squared minus 4x minus 7. And now we can do some elimination of terms. For example, the y and the minus y would cancel. The 7x squared and the minus 7x squared would cancel. The 4x and the minus 4x. The 7 and the minus 7. So we'd be left with delta y is 14x delta x plus 7 delta x squared plus 4 delta x. So we transfer that now to the next line, and we're going to now look for delta y over delta x. So we're going to divide everything on the left by delta x and everything on the right by delta x. So delta y over delta x is 14x delta x over delta x plus 7 delta x squared over delta x plus 4 delta x over delta x. Eliminating terms, delta x divided by delta x would cancel. Delta x into delta x squared would get rid of the square and just leave 1 delta x on top. And delta x divided by delta x, those two would cancel each other out as well. So delta y over delta x will be 14x plus 7 delta x plus 4. Now as delta y and delta x become very, very small, as delta x goes to 0, delta y over delta x is called dy dx. But as delta x goes to 0, this becomes 0. And multiplying anything by 0, it would disappear. So instead of 14x plus 7 delta x plus 4, we're just left with 14x plus 4. So that is the derivative differentiation from first principles. And if we were to do this using the general rule, if somebody said y is equal to fx is 7x squared plus 4x plus 7, to get the dy dx or the f dash x, the first derivative, we would say 7 times, then taking the 2 down, we'd say 2x, so that would be 14x. The differentiation of 4x would be just 4, and differentiating a constant would be 0. So 14x plus 4 in this way, and 14x plus 4 in this way. So that's how we would do it. We can prove it's correct there, and that's how we did it from first principles.